Hi everyone, welcome to the Function Junction, where we make math simple and easy to understand. Today we'll learn which method is best to solve a system of linear equations: graphing, substitution, or elimination. So far in this series, we've learned 3 different ways to solve systems of linear equations. We've learned how to solve them by graphing, we've learned substitution, and we've learned elimination. But if you're given a system of equations on a quiz or a test, how do you know which method to use? Should you graph it? Should you use substitution? Or should you eliminate one of the variables? Choosing the right method can save you a lot of time and make the problem much easier. In today's lesson, I'm going to show you how to quickly recognize which method is the best choice based on how the equations are written. By the end of this video, you'll know exactly what clues to look for before you even begin solving. Before we compare methods, let's quickly remind ourselves what a system of equations actually is. A system is simply 2 or more equations that are considered together. Our goal isn't to solve each equation separately. Our goal is to find the ordered pair that makes both equations true at the same time. No matter which method we choose, the final answer should always be exactly the same. The only difference is how we get there. Let's start with method 1, graphing. Graphing is usually the easiest method when you want to see what's happening. Each equation represents a line. The solution is simply the point where those 2 lines intersect. This method is excellent for building your understanding because you can actually visualize why the solution works. That point lies on both lines, so it satisfies both equations. What are the advantages of graphing? Graphing helps you understand the concept. You can also quickly see whether there is one solution, no solution, or infinitely many solutions. What are the disadvantages? Graphing isn't always the best choice. Sometimes the lines intersect between grid points. If the answer is something like 2.7 and 4.3, it's difficult to read the exact coordinates from a graph. Graphing is best when you need a visual, the graph is requested, or the intersection appears to be at whole number coordinates. Now let's look at substitution. Substitution works best whenever one variable is already isolated, or it can be isolated very easily. Here the first equation already tells us exactly what y equals. Instead of writing y in the second equation, we simply replace it with 2x plus 1. As soon as one variable is isolated, substitution usually becomes very efficient. What are the advantages? It can give an exact answer. You don't need to draw a graph. And it's often the quickest choice when a variable is already by itself. What are the disadvantages? If neither equation has a variable isolated, you may have to rearrange one first. That adds extra work. Substitution is best when one variable is already isolated. Isolating a variable only takes 1 or 2 steps. Finally, let's look at elimination. Instead of replacing one variable, elimination removes one variable completely. Notice the y terms. One is positive and one is negative. That means they cancel when we add the equations. The nice thing about elimination is that you often don't have to rearrange either equation. What are the advantages? It can be very fast, and it works especially well when equations are written in standard form. It's also excellent for larger systems. What are the disadvantages? Sometimes the coefficients don't match. When that happens, you'll need to multiply one or both equations before eliminating a variable. Elimination is best when variables already have opposite coefficients, standard form is used, or coefficients are easy to make opposites. Notice something important. None of these methods is better than the others. They're simply tools. Think of them like tools in a toolbox. You wouldn't use a hammer to tighten a screw. In the same way, choosing the right algebra method makes the problem easier. Let's take a look at some examples. Example 1. Which method would you choose to solve this system? Y equals 3x minus 2 and 2x plus y equals 6. Substitution would be best because y is already isolated. Example 2. Which method would you choose to solve this system? 2x plus y equals 10 and 3x minus y equals 5. Elimination, because the y coefficients are already opposites. Example 3. Which method would you choose to solve this system? Two equations already in slope-intercept form with simple slopes. Graphing. Graphing is a great choice if you're asked to graph or if the intersection looks like it will land on exact coordinates. Example 4. Which method would you choose to solve this system? 4x plus 2y equals 12. 2x plus y equals 6. These equations represent the same line. Graphing makes it easy to see that there are infinitely many solutions. Let's take a look at some common mistakes students make. A common mistake is choosing a method just because it's the last one you learned. Instead, take a few seconds to look at the equations first. Ask yourself, is a variable already isolated? Are there opposite coefficients? Would graphing give me an exact answer? Those questions can save you time and reduce mistakes. Let's summarize what we've just learned. When choosing a method to solve your linear systems of equations, choose graphing when you want a visual, you're asked to graph, or the solution appears easy to read. Choose substitution when one variable is already isolated, or it can be isolated quickly. Lastly, choose elimination when equations are in standard form, coefficients are already opposites, or they're easy to make opposite. Congratulations! We successfully learned how to determine which method to use to solve systems of linear equations. If you like this video, make sure to subscribe. Also, make sure to check out our other videos to continue your function junction journey. See you next time.